The next type of problem we're going to look at is the type of problem that's asking you what's happening to a solution as it's cooled. All right, so our example problem for this is that a mass of 80 grams of KNO3 is dissolved in 100 grams of water at 70 degrees Celsius. As the solution is cooled, at what temperature should solid first appear in the solution? All right, so first step in this is going to be to plot your ordered pair from the information that's given to you in the problem. So the information that's given to me in the problem is 80 grams of the solute at 70 degrees Celsius. My temperature is along my x-axis, so that's going to be my x coordinate, and 80 grams of solute is on my y, so that's going to be my y. Our ordered pair is always written x comma y. So this quickly flips into the ordered pair of 70 comma 80. I'm going to come down here and go ahead and plot that. I'm going to go over to 70. I'm going to come up to 80. I'm going to give myself a little mark to represent that ordered pair. I'm going to go back to my problem to remind myself of the compound that I'm working with. And the compound that I'm working with happens to be KNO3 right here. Now, this point in relation to KNO3's line is considered below KNO3's line. And as we know by now, if I'm below this line, okay, I'm considered unsaturated, all right? If I were to be on the line, I would still be considered saturated. So saturated and unsaturated solutions, and both of these solutions, and we'll start with a recap of unsaturated. In an unsaturated solution, remember that there's too little solute for the amount of solvent that we have, meaning we can dissolve more. It can hold more. I could dissolve more salt into the water. I could dissolve more sugar into the lemonade mixture, whatever it might be. Okay. The question is asking us, as we start to cool, so if I start to cool this point, if I come down and just look at my temperatures, okay, if I'm cooling, I'm obviously not going to be moving to the right, but I'm going to be moving to the left and decreasing from 70 as I come down in temperature. So I'm moving to the left. I'm not changing the amount or the grams of solute that I put into solution. I'm simply changing the temperature. So my y coordinate stays the same while my x coordinate begins to change, which is going to shift this dot closer and closer and closer to the line. All right. So eventually I end up at 50 degrees Celsius, smack dab on the line. Well, when I'm on the line, all right, that gives me a saturated solution. And to remember this, in a saturated solution means that you have the perfect amount of solute for the amount of solvent that you have. It can hold no more solute at the amount of solvent that you have. So it can't hold any more salt in the water. It can't hold any more sugar in the lemonade, so to speak. So in both saturated and unsaturated solutions, we should see no solid existing at the bottom of our solution. And what the solid is referring to is extra or excess solute. So for example, all of our salt would be dissolved in our water. We would see no salt particles at the bottom of our cup, all right? When we get into this above the line territory, which is considered supersaturated, that's when we start to see the solid appear in the solution, meaning we see an excess amount of solute. And that's exactly what supersaturation is. You have too much solute for the amount of solvent that you have. So you start to see it, what we call precipitate out of solution. And that's where you would see, oh no, I have some salt remaining at the bottom of my beaker. And that's it. When it says solid, it physically would look like this. So if this was a saturated or unsaturated solution, you would see just the water, no particles floating in there. And then when you get into the supersaturated solution, you might start to see little particles build up down here at the bottom of salt because they can no longer dissolve into the water. It's too full. Okay, so what this question is essentially asking is for the first point that you reach above that line, all right, which would be right about here. If you track that down, you can see that that would occur at approximately 49 degrees Celsius. That's where we should first see solid appear in the solution.